Okay, so now I'd like to show you how you can kind of write some code to center the map on the part of the world that you're interested in, rather than just the default center that we saw with with Earth Engine. And uh, and so what I mean by that is if I have this saved and I refresh Earth Engine, and I you'll see that we are back with um, centered on you know Kansas, and or was it Oklahoma? Yeah, so sorry, we're centered on Oklahoma, and we've also lost our base map. And so even if I bring up this this script that we just did and I hit run, um, it's going to we're going to be stuck with this kind of default center and base map. So what I'd like to do is, what if we're like to, when we run this script, if we'd like it to immediately focus on the part of the world that we're interested in and the kind of the extent, the zoom level that we're interested in. So to do that, we're going to go, let's look over here. We're going to write some code, and I'm going to go over to docs. And this thing is basically the documentation. It's like the help file where it's telling you all of the methods that are available that we have to work with in Earth Engine. So if I go under map, you'll see that there's this thing called um, map set center. And if I click on that, it's going to tell me that this centers the map view at a given coordinates with a given zoom level. And the given being you can pass the longitude and the latitude and the zoom as arguments to this function that is a method of this map object. Is that fair? And then it returns kind of an updated map. So here's what that looks like. I'm going to go grab the snippet from the primer, and we're going to center and set the zoom level of the map by using this map set center, and there's my parentheses, and I'm going to pass it three arguments. And I'm using a lot of white space here, just so that I can comment it out and kind of remind you that, remember, it's X, Y, and X is longitude, Y is latitude, and the third thing is the zoom level. So if we now hit that, it's going to zoom out, and it's going to zoom to where -50 and -4 are the center of the map, and the zoom level is 3. And we can test that if we just want to say print. Um, we can say get center, right? So if we say map get center, just as a test to see if this really works, it's going to say, well, we're at -50 and 40. And then similarly, if I say I'd also like you to print map get zoom, which is a function here, returns the current zoom level, and return it, you can see that it's doing what we would like. So let's say you want to go and zoom on by Hall. And so I'm going to go switch. I'm going to go to Middlebury. Really? Haha. And then you're going to click on it, and it's going to go to Middlebury, and I'm going to be able to see by Hall, find R2D2, and then I'm going to grab my inspector, and I'm going to click on R2D2 there, and I've got longitude and latitude, and you can see that it's specified into a great amount of detail. And what you'll find is that there's actually one extra decimal place, in this case for latitude than in longitude, because it's using it's basically using a data point here for the negative sign. And so the thing to kind of realize is that this longitude and latitude that you get when you click on using the inspector is going to give you a precision that's based on just what this data type can store. But it's a little bit meaningless. And so let's go ahead and so this is kind of like the Spinal Tap thing of like it goes to 11 and it's kind of doesn't really get you a whole lot. So let's go ahead and copy these in, and then see that our zoom level is 18. Oops. And then I'm going to zoom out and kind of like I'm going to mess up the Rubik's Cube, right? We just kind of zoom out and go to a different place. and then hit run, and we should get back at Pi Hall. The only drag here is that we've lost our base map. We'll talk about that the next time. But we're back into our the scene that we want to be. We're at the right location. So I think what you'll find is that, first of all, if you take out this, let's take out one level there and say, what's the result if I remove one decimal place of my latitude and hit run again? You're going to lose the base map, but this thing didn't shake at all. And so I think what you'll find is that as you take away these numbers, it doesn't really have much of an effect until you get to a certain point. So let's zoom as far in as we can and kind of run through this a little bit. And we're just looking for when do we get a shake. So I'm going to delete here. Oops, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's that. Still no shake. There's this. No shake. There's this. No shake. There's this. No shake. No shake. So we're getting kind of trim here, right? All right. I still didn't see a shake. How about if we take that off? There. So I'm going to undo and bring those back. And so the point being is that this is kind of what are significant digits, is that you don't, it looks to me like even if we zoomed way in, we don't really start affecting our location value if we're more than 1, 2, 3, 4, 5. Kind of like 5's all you really need. And to be honest with you, if we zoomed out, you probably wouldn't even need 5, right? If we took out 1 here and not a noticeable shake. Is that fair? So the main point is that um, sometimes with computers, the data that you get is based on the precision that can be stored by a certain data type, but it may not be particularly meaningful. And that's the idea that you are often given a lot of insignificant digits in your reporting, and that's just a quick reminder of that. It's kind of no harm and it's fast to just copy and paste the whole thing, but it's not necessary to do it, as if that's fair. Okay, so let's go back in here and let's do the next bit. We're trying to figure out if we can make this so we don't lose the satellite view every time we hit run.